All right. Hi, everyone. Welcome to our second featured speaker event hosted by STEM2girls. My name is Jovita D'Souza, and I will be hosting and helping this presentation along with Karen. It's so wonderful to see you all here today, and I'm so excited to work with you guys. Just a few quick things before we begin introducing ourselves. This session is recorded, and a recording will be posted on our website shortly. Please do not record or screenshot this meeting from your end or share the meeting link with anyone else during the presentation. This is going to be a casual Q&A session, and your video will not be seen in the recording unless you are Katelyn, Kara, or I. We ask that you do not unmute at any time during this meeting, and any questions you have can be asked in the chat directly to us. STEM2girls is a student-led nonprofit organization that empowers girls and women to pursue STEM careers by providing STEM-related workshops, resources, and opportunities. Despite being a relatively new initiative, we are planning several speaker events such as this one, ACT preparation, and other engagement opportunities for high school and elementary school students as well. At STEM2girls, we are committed to informing and encouraging girls to pursue careers in science, technology, and engineering, and mathematics. Our vision is to create a world where girls have confidence in pursuing a STEM-related career. We are accomplishing this vision by providing free and accessible academic resources, hands-on events, and opportunities for girls to connect to professionals in the greater Green Bay area and Northeast Wisconsin. We also have some of our contact information, such as our social media and our website, on the slide if you would like to learn more through those platforms as well. And now to meet the host, my name is Jovita D'Souza once again. I am the Secretary and Chief Operating Officer of STEM2girls.
Hi, I'm Kara Reen. I'm the President as well as the Chief Executive Officer of STEM2girls.
Once again, if you have any questions at all during the presentation, please enter them in the chat and we can try to answer them at the end of the presentation, or maybe they might get answered during the presentation as well. And Kara, I will hand it to you to introduce our next speaker.
All right, I am honored to introduce Katelyn Desrochers. Katelyn Desrochers is a mechanical engineer who obtained her Bachelor's of Science in Mechanical Engineering from the University of Wisconsin-Green Bay in fall 2020. And she's ambitiously working to obtain her AAS in Automation Engineering Technology from Northeast Wisconsin Technical College. During her college educations, she was inducted into Michigan Technological University's chapter of Tau Beta Phi and the oldest engineering honor society for integrity and excellence in engineering. Katelyn has previously interned for the Marathon Petroleum Corporation in Detroit, Michigan, and Catlettsburg, Kentucky, as well as 3M Company in Maplewood, Minnesota. Through speaking and mentoring high school females, she is changing the conversation of STEM and redefining the engineering culture through normalizing failure and diminishing insecurities. Thank you, Katelyn, for coming, and I'm excited to listen to more.
Yeah, thanks so much, guys, for having me.
So I'm going to start with my first question, and that's, what were some of the steps you took to attain and prepare for your co-op with the Marathon Petroleum Corporation?
Yeah, so I got my internship or co-op with Marathon when I was attending Michigan Tech. So this is a picture of me and Blizzard. I was in the Huskies pep band for a while. And honestly, talking about my co-op is one of my favorite things to talk about because it's a really fun and cool story. So it starts on day one, a Tuesday, the day before career fair. And basically, there are some companies that will go and set up booths in the heart of Michigan Tech's campus, and they call this career fair cookout. So basically, you can go and network with as many or as few employers as you want to the day before. And in exchange for that conversation with the employer, you end up getting a ticket for like a brat or a bag of chips. And as a college student who didn't have time to cook, really the money to cook or the mastery of cooking, right? This was a really, really great opportunity for me. So I went walking up to somebody who had worked for Marathon, and she was one of the first women that I felt like I could really relate with in terms of just, having an open conversation about STEM. And so she had really encouraged me to go find her at career fair, which is now day 2 of the story, Wednesday. This is what career fair looks like at Michigan Tech. So there are a whole bunch of booths set up basically in the gymnasium, and you are free to mingle with as many or as few employers as you want. So I went and I hunted her down that Wednesday, and I handed her my resume, which looked like this. And basically, as you can see from my resume, I didn't have any experience in engineering at all. So she basically encouraged me to apply anyways. So I went home that night and I applied, and I got a phone call later on saying that, hey, we'd love to interview you. Which brings us to day 3 now, Thursday. I'm interviewing in the basement of the alumni house at Michigan Tech. And it was a really awesome conversation, but I wasn't really quite sure if I would get the opportunity or not. So I was really excited when I woke up day 4, Friday, and I had received an offer letter from Marathon to go live in Detroit and work in an oil refinery. And it was a really awesome opportunity, but I felt kind of torn because I was only really in my second semester of mechanical engineering, and I was leaving behind everything that was familiar to me. But ultimately, what I decided was that this opportunity wouldn't always be there, but my friends and the studies would be. So I took the jump, the plunge to go work for Marathon in Detroit. And looking back at it now, that was definitely one of my best experiences in college, and I think one of the coolest experiences I've had as an engineer. Now, in terms of how I actually prepared for employment, that's a little bit of a different story. So I was living in Houghton at the time, and I was moving to Detroit. So that was a little bit of a haul. I had to find somebody to basically rent my apartment for me in Houghton. I'm at least thankful that Marathon had housing available for me. So they actually put me up in this townhome. So I didn't have to worry about finding a place to live when I was in Houghton, which was 8 hours away. And that was really nice. And they also gave me a stipend to move and to offset the cost for some of the housing. So that was really, really nice. But in terms of, preparing for day 1, right? How do you prepare to work in an oil refinery? I'd only ever seen pictures before, right? So my parents were trying to be helpful, for my first day, and they wanted to drive me to the location. And so we got there and it looked a little bit something like this. And there's a whole bunch of flare stacks and fireballs shooting into the sky, and it was really quite overwhelming. So this picture too is a little grainy, and this is a little bit of a better picture of that. So this is the refinery's coker, and this thing is 350 feet tall. So it's absolutely massive. The Statue of Liberty is actually 305 feet tall, so it's even bigger than that. And one of the coolest parts is there's a freight elevator that takes you kind of up to this loading area. And then the rest of it is complete vertical ascent. So you're kind of on your own in terms of making sure you're safely getting up there. And once you're up there, though, it's really cool because on one side you can see the Canadian skyline, and on the other side you can see the Detroit skyline. So maybe not for you if heights aren't your thing. That was a really, really cool opportunity. And honestly, I don't think anything could have prepared me in advance for working on such a big piece of equipment. So it definitely took some time to get more comfortable for sure.
All right, that's sounds fun. I'm a little scared hearing that about the heights. But my second question is more about the projects you've worked on. So can you tell us more about the projects you've worked on in the past and how they've helped you expand your career opportunities?
Yeah, so one of my projects at the Detroit refinery was to go through and make sure, so we had done a new installation, make sure that the installation was done correctly. So that is a really, really tedious task, right? To be able to walk down all of this piping and verify where the different valves are. So all of that knowledge is basically stored on this thing called a process and instrumentation diagram. So basically that doesn't show you physically what it looks like, but it shows you like, okay, this valve is connected to this piece of pipe, and then this goes to this section of the different pieces of equipment. And so walking that down is really challenging, right? Because this piping is not straight. It doesn't run in straight lines. That'd be really nice if it did. But it's straight for a little bit, and then it ascends, and then it twists and it bends, and you're holding your drawings out there and the sun is shining in your eyes, right? You're trying to follow it with your highlighter and you're not really sure, sometimes what the weather's going to be like. So seems like a simple task, but super tedious. But learning how to read these process diagrams once you get going with it is super simple. It's just like learning a new language. And it is also really, really helpful for other projects that I would work on later. But I also remember being a mechanical engineer and kind of thinking to myself, right, like I'm learning about piping and this is very much a chemical industry, right? Like, when am I ever going to use this again? But it was really interesting how transferable that knowledge has been, because the same kind of piping and process instrumentation diagrams that you use in oil refineries, you also use in things like making candy. So instead of moving petrochemical things all over the place, you're now just moving sugar and water places, right? Same thing for different beverages like bubbler or Coca-Cola. It all basically goes down to that process and instrumentation diagrams. So that was really cool and really fun knowledge that I've been able to transfer across a couple different industries now. Switching gears here, I also worked as a design and engineering solutions intern for 3M company. I had worked on this thing called a drum winder, and this was the closest thing that I could find to that. So there's kind of this spool down here that you guys can see. And this spool can have a whole bunch of different materials it's made out of. And it goes through a series of rollers. They can be nip rollers, they can be small, big, they can almost look like pulleys, but basically it goes through a series of those. And then it collects on this drum back here. So this part that's in front traverses a lot of times left to right. So what happens then is you can heat up this drum and basically cut off the thing that is heated so it all kind of sticks together and makes sheets of things. And so learning on a small scale like this, how to read web handling drawings is really, really important. So understanding, right, web handling, how we get this material from down here to on this drum. But it also really taught me how to safely guard different pieces of equipment. So if we're looking at the distance between this big drum in the background and this roller up top, that's technically called a nip point. So on a piece of equipment like this, where it's a little bit smaller, somebody might break their finger. But on a piece of equipment like this, where you are working on paper manufacturing stuff, right? People can get entangled in these pieces of equipment really easily if you don't guard them correctly and you don't educate your operators on safe work procedures. So, right, that knowledge of how do we guard things and how do we build a safe machine on a small scale is so helpful for when you go to work on things at a bigger scale, right? And again, that same transferable idea of how does the material from one section of this machine go through a series of rollers to get to the other section of the machine? So paper uses this quite a bit, and obviously Green Bay has a lot of paper manufacturing. This knowledge was also really helpful, though, when I went to go work on different pieces of packaging equipment. So this is a picture of a labeler, and you can kind of see the labels. I shouldn't have got rid of my pen. You can see the labels right here. And basically the labels go through another series of these web handling things, and they get applied to the different product that's coming through. And you can also see kind of over here, this is like a desiccant dispenser. So a desiccant is like that silicone packet that you get that says do not eat on it. That goes through a series of web handling as well to be able to drop into the product. So again, another place where it's really great to know how web handling works. And this piece of equipment now is so interesting because it kind of ties into what I'm learning now, which is how do we automate these systems, right? Because it would be a really bad business plan or a really inefficient business to have somebody ripping off these desiccants and manually applying each one of these labels here, right? So now I am working on, oh, I gotta delete that, sorry. I am working on how do we automate these systems, right? So this is a image of one of the machines that I am working on at Northeast Wisconsin Technical College. So basically we have 4 different conveyor belts here that go and feed this one big long conveyor belt, and that transfers it into a hopper. So I was responsible for making the interface of that machine, right? So in a perfect day, everything's rainbows in manufacturing. We hit the automatic button, we hit the start button, and basically what happens is we have this batch count here. This is the number of each one of the blocks that I want to go into my product. And the machine runs to jog each one of those materials until the batch count is equal to the number of current blocks in the batch. And that would be great if that did that consistently every single day, but obviously manufacturing does not work that way. So sometimes what we can do is we can switch into manual mode. And in manual mode, instead of having the machine run as one continuous unit, right, I can go ahead and I can jog each one of the conveyors. And that's also really important for, you know, if one of my conveyors breaks down, right, I'm still able to keep part of the production going. I can also see in here, right, I have this low and empty photo eyes in there. So that really helps me prepare, right, my operators to say, okay, I need you to go put more materials in this hopper to keep our production going, right? So really, really cool and fun to make these interfaces. But behind the scenes of all this, there is programming going on. So basically that programming looks like this. And they call this rung logic programming. So I have the way that I kind of think through these is I have this left-hand side and I have the right-hand side. So if I'm looking at, you know, the left-hand side, how does that impact the right-hand side? So this first, they call them bit, says material 1 chain drive run command. So somewhere else in my program, basically what it's saying is I want my material 1 conveyor to jog. Right? I want that to start happening. So that is true, right? And then I go and I look at this bit, which says material 1, it says mas.ip. So, and then there's this little slash mark that's through this bit. So basically this MAS stands for motion access stop. And then the IP stands for in progress. So essentially it's asking somewhere else in my machine, am I commanding that first conveyor belt to stop, and is that in progress? And since that slash in here basically says for, you know, are we looking for this not to be happening, right? That's good too. So then I look at my right-hand side and I see that I have this move block in here. So just like that screen that I was showing everyone before, you can go and input a whole bunch of different speeds. And so that's essentially where it gets this input from, and it has to move it into this tag. And then so we get kind of over to this MAJ then, which stands for a motion access jog. And basically that's finally the part that says, okay, I want to jog my conveyor, right? So what direction do I want it to go? What do I want the speed to be? How do I want to accelerate or decelerate? You know, and any jerk parameters that are kind of associated with that.
All right, thank you for the explanations. It's so interesting learning the processes behind each of those machines. And I wanted to ask you a general question about what inspired you to pursue your current path.
Yeah, so growing up, at my grandma's house, my cousin and I would take some VHS tapes off the shelf and we would actually make Rube Goldbergs in our basement. So for those of you who don't know, Rube Goldbergs are chain reaction machines. And we would kind of line them up like this. And then sometimes we would take Tinker Toys and build different other segments of the machine, all to accomplish a simple task like putting a can into a recycling bin or to pop a balloon. And we would literally spend hours together in her basement, kind of going through these different ideas. I also took any and pretty much every opportunity to steal my brother's Connects and Legos because at the time, Legos and Connects weren't as diversified as they are now. So this is a picture of a paintball launcher that one of my friends and I made for one of our physics classes. So we would basically load the paintballs kind of in this back section, and then we would take this outside and set a camera up with chalk marks on the ground at different space intervals. And basically we would go and launch these paintballs and then watch back to see how far the paintballs went. And also through counting back frame per frame, we were able to see, how many frames it took for the paintballs to get there. So how fast it went. So really fun, kind of exciting. Also, before you could get science literally in the palm of your hand, Mythbusters was really, really big. And so I really enjoyed being able to watch them, and they kind of encouraged me to test my own science experiments and see how they would go. And I think overall, this is going to sound really quirky, but I enjoyed studying the movement of things. Asking questions like, how do car tires actually work? Now I'm really diving into the questions of how does this different piece of automation equipment work, right? So having my bachelor's degree in mechanical engineering is really complementing my associate's degree in automation engineering technology.
All right. So I want to ask, what is the most helpful resource that has helped you or is helping you over the course of your degree right now?
So it's a really simple resource, but honestly, it's probably Google Calendar. When you go off to college or you begin adulthood, right, you're trying to juggle everything from going to your classes. You are trying to work a job, you're trying to clean your dorm, go to your extracurriculars, and literally everything else that you can possibly think of in between. And not having a calendar and trying to do all that stuff at one time is really challenging. So this is literally a screenshot of what my calendar looks like coming up in April. And it shows everything that I'm doing. So appointments that I have to go to, classes that I'm in, some extracurriculars that I'm involved in, right? But what it doesn't show me is, how much time does it take for me to travel to get to these different locations? It doesn't show me when I'm going to eat my lunch or even the times that I'm studying, right? And that's all stuff that you have to have time for as well. So for me, really having those hard commitments on a calendar and being able to see, right, when am I actually physically committed, helps me kind of juggle the other stuff that I'm working on and the other necessities as well. And learning how to gauge your time is a really important skill to learn. And it helps you manage your time a lot better when you're an engineer. I'd also say learn how to say no. This is something that I'm definitely learning how to do as well. Right now, I am really busy with going back to school and going and doing a whole bunch of STEM engagements. I am one person. I only have so many hours in the day, and I really am trying to learn how to allocate my time to my priorities. So it is okay to say no. It is okay to say we need to do this another day. The people that you're saying no to are people who have likely said no to others in the past. So just know it is okay to say no. So more so to my bachelor's degree, I used a lot of office hours, more so than what I'm doing now. Those are really, really awesome for if you're not understanding things, but also to build rapport with different instructors. One of the first classes, if you go into mechanical engineering, that you'll take is statics, which is the study of rigid bodies, essentially the forces in rigid bodies. And it's kind of an unwritten rule that you're supposed to know what a dot product and a cross product are prior to going into that class. And I had no idea what either one of those things were. So I passed my first exam with a 62%. And I went to the professor, and the professor was like, what happened? Right. And, I was crying in front of this guy, and I'm like, well, I didn't know what a dot product or a cross product were. Right. And he was just like, all right, we will figure this out to make sure that you don't fail this class. So I ended up passing the class. I was so proud of that class, and that knowledge that I really gained and was able to successfully master in statics really helps me for when I went to go do dynamics, which is the study of the forces in bodies in motion. So really the sister class, that was another class that I used quite a bit of office hours for. And that's a professor. I still keep in touch with her today. So using office hours not only is a great way to gain mastery of concepts that you're studying, but it's also a really great way to kind of put your foot in the door for if you want to do a research project or even use people for references later on.
All right. Sorry, but my next question is, what are some of the challenges that you have faced as a woman in the STEM field? And have you been the only woman in the room or in a project where there's very few women involved?
So this is a picture of me with some of the guys at the University of Wisconsin-Green Bay. And it's really hard because, one of the biggest challenges, I think, to being the only female in STEM is that you just feel like you don't fit in or you don't belong. And these guys were super cool because they never said anything like off-putting to me or anything like that. But, obviously it was hard because it felt like all my friends were men, and for the longest time I almost felt like there was something wrong with me about that, right? Like, why don't I have more female friends? But I would go to school and it'd be all men. I'd go to work and it would be all men, and I'd go to something I was interested in and it would be all men, right? Eventually it slowly dawned on me that there wasn't really anything wrong with me. It's just that I was literally surrounded by all men, right? And I think, that's true for a lot of kind of my professional life and other activities, like I said, that I was involved with. So this picture on the left was when I got second place for innovation in aging at the University of Wisconsin, or first place for innovation in aging at the University of Wisconsin-Green Bay. Once again, all men. And then on the right-hand side, these are the guys that I did the co-op with at Marathon Petroleum Corporation in Detroit. And once again, they're all men. And it was kind of funny for the oil refinery because, they send you outside and they give you like a fire retardant clothing and steel toe boots, a pair of safety glasses, and a hard hat. And everybody after a while, all these big husky men kind of start to look the same. But I was still a very little 5'1" Katelyn, right? And sticking out like that all the time is really, really hard. In some respects, it is really exciting because I am trailblazing. I was the first female to graduate from the University of Wisconsin-Green Bay's mechanical engineering program. At my last employer, I was the first female ever to work as an engineer there. And that's all very exciting to be a part of. But at the same time, it comes with a lot of pressure and a lot of isolation. And it's been very difficult to talk with other women kind of about that. Because I think STEM and specifically engineering is kind of a little bit of a different beast in terms of, acceptance. So I haven't always found that. I guess some advice that I would give for people is to really advocate for yourself. If people are saying things that are sexist or misogynistic, it is okay to speak up, right? You might be labeled, but ultimately you are doing what you need to be doing for you. And I think also know that these comments that people are making are by no means a representation of your engineering capabilities. They are simply a representation of their beliefs of you. And that can be really, I think, challenging to deal with at times because, right, like it's personal, but it's not personal. So I think really thinking about it that way, though, has helped me just know that, the work that I am doing is meaningful and doing something impactful for the world. And that's what's important to me. I think another piece of advice that I would definitely give is, if you are stuck in an opportunity, let's say it's a job or even school environment, that you feel like, I'm not being respected, I need to leave. It is okay to leave. I sort of felt like I had almost given myself this oath, right, that I wasn't going to let anyone push me out. Their comments are their comments. But at the same time, I was put in a very sexist and unfair situation, and it was something that was not going to get better. Their sexist and misogynistic comments are their comments. And I knew, right, like I said earlier, that was kind of their problem. But at the same time, I was at the point where I just needed to leave this situation. And, no matter where you work or no matter where you go to school, whichever way you want to flip that coin, if management or leadership is unwilling to adapt, and this is management or leadership driven by both men and women, if they're unwilling to adapt, make changes, or take your feedback into consideration, they are consistently perpetuating the unnecessary jokes, comments, and stereotypes, and you deserve more than that. So it was an incredibly hard decision for me to leave where I was at, but I'm incredibly happy now, and I really am sincerely looking forward to my next opportunity as an engineer, where I know that I will find a group of people who will respect me.
All right, so for the next question, I have advice more for students my age. So what would be advice you would give to high school students looking to pursue a career in mechanical engineering?
So I think pretty standard advice that people give is to take a lot of math and science classes. I think what I would say to people is your journey may be messy, but that's okay. Focus on making your journey your own, and emphasize what is really important to you. So this is a really big high overview level snapshot of my college journey. I actually started in the fall of 2015 at the University of Wisconsin-Green Bay, and I was undeclared. I had no idea what I was actually doing with my life. It wasn't until I transferred in the spring of 2017 and attended Michigan Tech that I finally declared my major in mechanical engineering. I took a semester off to go work. I had a semester that was a mess. I ultimately decided that I wanted to save some money, so I transferred back to the University of Wisconsin-Green Bay to finish my bachelor's of mechanical engineering in the fall of 2020. And that took me 5.5 years. And that's okay. Like, it's okay to take more than 4 years. I recently quit my job and I decided I wanted to take another plunge and go back to school to Northeast Wisconsin Technical College and get my associates in automation engineering technology, which has been a really, really fun program. And I'll be graduating this spring. And I don't really know quite yet where I'll be working or what I'll be doing, but I am a lot smarter today than I was yesterday. And I think that is really critical for self-growth and reflection. So make your journey your own and make it uniquely yours. I'd also tell anyone who wants to pursue a career in mechanical engineering to be ambitious, right? I look back at a lot of the early opportunities I had, and I kind of asked myself the question of why did I have these opportunities, right? I've never been the smartest person in the room, but I definitely argue that I'm more ambitious than the person sitting next to me. My senior quote was actually, "Intelligence without ambition is a bird without wings," right? If you're intelligent but not ambitious, what's the point? And I think that being ambitious really showed my prospective employers that I was willing to learn and overcome the obstacles that continue to stand in my way.
All right, thank you for the presentation. And I want to say I love your senior quote, and I specifically love how you said to advocate for yourself, whoever is in management, to stick up for yourself, and that staying in that environment and being compliant actually upholds and reinforces stereotypes or jokes. I think that's really impactful and something people have to take into consideration in an environment where they're not welcomed. I have a couple questions for you, and my first one follows back to what you were talking about in the beginning with the marathon. So what was your favorite part about working at Marathon?
I think just the fact that, like, if you can imagine, like, probably the perception that ants have in the world that we live in, right? That's literally what it felt like, just I've always been super passionate about wanting to work on really, really big rigs, and that definitely delivered in terms of big and feeling like an ant all the time. Just that. And I think the amount of knowledge that I was really able to glean from that opportunity and how it's lended itself to other things. So I definitely go back to that one in a heartbeat.
Our next question is, what is some advice that you can give to students who are looking for internships or co-ops, especially in terms of how to reach out and connect to those opportunities?
Yeah, so like I said, my story for how I got my co-op was, right, like I kind of wanted a brat. Like, if I'm being perfectly honest with you, I definitely really didn't think anything of that interaction. So in another presentation that I give quite a bit, networking and establishing your credibility is really important to other employers, and starting that kind of early on with different jobs you work is a really easy way to do that. So don't be afraid, right, to build a resume when you're 16, right? And go and get input from different people on things that you might need to tweak, right? I'm currently working on getting my resume tweaked, like everybody does it. So really have your resume, but also, right, be ambitious and put yourself out there. Another really cool opportunity I had in college, Fiat Chrysler Automotive was on campus at Michigan Tech. And again, they probably had a squish ball or a bag of chips or something that, right, really attracted me because I was a college kid. And I went and handed my resume to them. And I didn't really think much of it. I'm like, all right, here's my resume. Have a great day. But they called me back, I want to say like a day or 2 days later. And they're like, hey, we really like your resume. Would you like to do a ride and drive share event? So we were literally taking like, different chargers and like a whole bunch of really fast vehicles. And we got to go up and down the Keweenaw Peninsula at like 100 miles an hour. And they paid for the event and the food, right? All because I handed somebody my resume, right? So don't be afraid to network. Don't be afraid to, have a solid resume and to start working on that now.
Okay. Somebody also asked if you ever struggled with confidence and fear of making mistakes, especially with some pressure, and how do you overcome those feelings?
Yeah, so confidence is definitely something I think that when you're surrounded by a whole bunch of people that don't look like you, can be something that you probably will struggle with. And I think just to make the point too of, engineering is hard, right? I don't think people go into engineering degrees because it's an easy feat, right? I think they go into it because you got to like the challenge to some extent. So definitely, being confident has been challenging. But I think that one of the things I've learned along the way is that the guys are just as insecure, if not more insecure than we are. We're just more vocal about it. And that was from one of the conversations that I had with one of my professors at Michigan Tech when I was having a really hard semester. He's like, the guys, they struggle too. They're just not as, overt about it. So that has been challenging, but, I think just gaining more knowledge and being more confident and finding people who actually respect you is really helpful to kind of circumventing some of those problems.
Okay, our other question is, what was the hardest class that you had to take during college, and what strategies did you use to, manage the course load?
That's a hard question. Um, so if I had to think back through part of my college career, I definitely say Calculus 2 for me was really challenging. That was one of the first deer in the headlights math classes that I ever took, where she's like, yeah, you just plug this number in here. And I'm like, that doesn't make any sense. Like, I don't know how to get there with you. I'm sorry. Because I think that one has to do with a lot more abstract reasoning than some of the other math classes I had to take. So definitely went to a lot of office hours for that one as well. Just not being afraid to ask questions when I had them. So Calc 2, I mean, obviously statics, that class was really hard, but that's because I didn't have the prerequisite for the class. So that tends to make things a little bit harder. But, I think one thing that you'll learn through going in different STEM degrees, and like for me specifically in engineering, and other people have said this as well as I have conversations with people, the classes honestly don't get easier. I think you just get better at, understanding the concepts, because once you kind of get over the first hump, right? Like I said, of, okay, this is what statics is, and dynamics is just essentially the same concept, plus let's put it in motion, right? It's really not that much more complicated. So I think just the fact that they grow and you kind of get used to and building those really good study skills and rapport with your professors. So I think for me, honestly, it probably got easier.
Okay, I had a few people ask you about your future plan in your profession and what's next for you.
Yeah, so that's a really exciting question. I'm not honestly really entirely sure yet. So my plan is to work kind of more as an automation engineer. So one thing that I have found in terms of my bachelor's in mechanical engineering is it put me kind of more in a desk role where I was doing a lot of project management, and the oil refinery was really cool because I was out in the field a lot. But it was still very much like a facilitator role. And then when I worked for 3M, that was really cool to be designing stuff, but you're sitting at a computer. And a lot of times when you work for bigger companies like that, the thing you're actually designing stuff for is in South Dakota, right? And you are in Minneapolis. So really having that disconnect from my work was something that I just didn't necessarily care for. So in my next role, I think I'm really looking for an opportunity to be a lot more hands-on with things. And I think being hands-on with things really helps you kind of build your knowledge and troubleshooting skills. So when people are talking about automation equipment, right, you're kind of able to not only understand from an engineering perspective, but also from, an operations perspective, how things work, because those are two completely separate buckets. I think the other thing that I'm really looking forward to continuing to do is to do more STEM outreach. I have a little mentorship group at West High School. I'm hoping to continue to do that. I'm currently traveling in the Northeast Wisconsin area and doing lots of different outreach events. So really, really busy with that, and I hope to continue that as well.
Awesome. So I believe that is all the questions that we've had. So I would just like to say a huge thank you to Katelyn for sharing with us. Your experiences are so unique and your drive and efforts are so clear. So we really wish you the best as you do take the next steps in your career. And a huge thank you to everybody else who joined us today. And on our next slide is some contact information if you would like to learn more about how you can contribute. And with that, that brings us to the end of our speaker session. So thank you to everybody who joined.
Thanks so